Now let's talk about what to do when we have to find out when our functions intersect more than once. So find the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. So one of the things that we can see here is that we have two separate areas here. So our two areas being this area and this area. So those are the two areas that we need to find. We have two different functions. We have an x cubed function and we have an x squared function. So just kind of getting those out of the way of which one's which. Our x squared is a parabola. So if we look at here, this is doing more than a parabola is doing, which it looks like a cubic. Means that this one right here is f of x. This one right here is our g of x equation as they are written. Okay, these ones are in terms of x right now, and if we look, that means our area is going to be vertical, so we're going to be using x as our bounds, so we're going to be looking at top minus bottom. The other thing we're going to do is we're going to find these two areas separately and then see what happens. If we look here, it looks like we're hitting negative 2, 0, and 2, but we will once again do those bounds so we can see what that looks like and make sure that they are for sure. So we have our area is equal to, I'm going to call this a sub 1 and I'm going to call this a sub 2, so that way we can kind of look at them at different entities. The first one's going to be our first function is a sub 1, so we have the integral from the bounds that we don't know yet, and we need to decide top function minus the bottom function. If we look here, our vertical line would look like this, so the function that's on top here is this line. That means that if I follow this line, it's going towards that f of x function. So f of x in this case is our top function. So when we do top minus bottom, we're going to do f of x, so that 3x cubed minus x squared minus 10x minus our bottom function here, which in this case would be the other one of negative x squared plus 2x. This is just the first integral, so we're also going to integrate for the second one. We don't know bounds on the second one, we can assume what they are, and we're going to do top minus bottom again. Okay, this time our top function is this one right here. If I follow, it's going to be g of x. So now we're just flip-flopping which one is our top and which one's our bottom. So I have negative x squared plus 2x minus 3x cubed minus x squared minus 10x dx. Okay, so we have f of x equals g of x. So we're finding our bounds. So we have the 3x cubed minus x squared minus 10x equaling to negative x squared plus 2x. The first thing that I want to do is I want to move everything over to one side, so that way we can get one side equal to 0, which will help us in the long run. We're going to add x squared to both sides and subtract 2x from both sides. Okay, in doing so, 3x cubed stays the same. We have an x squared, we're adding 1 to it, so we have 0x squareds now. We have negative 10x, we're adding 2, so we have minus 8x. And if we look, that x cubed isn't as scary anymore because now we're just looking at what they have in common. Also, I said subtract on one side and add on the other. What am I doing? If I have 10x and I subtract another 2x, we're going to have 12x. Okay, so now that we've done that, we're going to find out what they have in common. The two things that they have in common are a 3 and an x. So I'm going to factor out a 3x from both things. So from both terms, I'm factoring out 3x. 3x times x squared is what gives me 3x cubed. 3x times negative 4 is what gives me minus 12x. And now we're going to set both of these equal to 0. So I have 3x is equal to 0. X squared minus 4 equals 0. 3x equaling 0 means that x is equal to 0 because we're going to divide both sides by 3. X squared minus 4 equaling 0 means that x squared equals 4. And x squared equals 4 when x is either positive or negative 2. So plus or minus 2 is where this part comes in, and it comes in here because when I square something, I'm multiplying it by itself. So if I have a negative times a negative or a positive times a positive, that's what I'm multiplying together. And this is different than when I have a square root already in my problem. I am performing a square root here to unsquare something, but because I have the possibility of that sign being almost erased because we're multiplying by itself, I have to think about plus or minus. So we want to go from negative 2 to 0 and then 0 to 2. So our first interval is going to be negative 2 to 0, then 0 to 2. From here, we would evaluate what we have on each function. So we would antiderive and do all of these things. So the first thing I'm going to do is then simplify what we have. So we have the integral from negative 2 to 0 of. So I have 3x cubed. I have a negative x squared, but we're going to be adding an x squared to it, so that goes away. I have a negative 10x, and I'm subtracting 2x. So we get all of that is just the integral from negative 2 to 0 of 3x cubed minus 12x. And then we are going to add the integral from 0 to 2 of, we have a negative x squared minus a negative x squared. We have a minus 3x cubed. So the x squareds go away, and then we have a 2x minus negative 10x. The minus and negative turns it into a positive. So this is what we're dealing with. And you're going to notice that these are very similar, except for our signs are a little bit different, and it's because of how we had to subtract things. So now we're going to integrate. So I have 3x cubed is going to be 3x to the 4th over 4 minus 12x squared over 2, which would be 6x squared. And that's going to be evaluated from negative 2 to 0. I'm going to add brackets here this time just because we have two different functions we're working with. Plus the antiderivative of negative 3x cubed. We have negative 3x to the 4th over 4. And we have 12x squared without the negative this time, so we are going to have 6x squared on the interval from 0 to 2. Okay, so we plug in the top value and then the bottom one. So I have 3 to the 4th times 0 over 4 minus 6 times 0 squared. Thankfully, those two are going to go to 0, so we're done with that one. But we have 3 times negative 2 to the 4th power divided by 4. We have minus 6 times negative 2 squared. I can simplify one and then write out the other, or I can write them both out and then simplify it all together. So our second part here, we have the same thing, except for x to the 4th over 4 is negative. Okay, so we're plugging in 2 for this one and 0 for this one. So I know this all goes to 0 here. where the zeros are, that all goes to 0 where the zeros are. So I'm looking at whatever answer I get for this is negative. So I have negative 2 to the 4th power, so that's negative 2 squared and then squared again, so negative 2 times negative 2, which is 4, and then I'm multiplying it by another set of 4. So 16, but we're also dividing it by 4, so I have 4, and we multiply by 3, so I have 12. I have negative 2 squared, which is 4, times 6, which is 24. So I have 12 minus 24, and that's all negative. And I'm going to add it to 2 to the 4th power divided by 4 times 3. So 2 to the 4th power divided by 4, we found out is 4. We multiply it by negative 3, and we get negative 12. Plus 6 times 2 squared. 2 squared is 4. 6 times 4 is 24. And then we're subtracting 0 from that. So I have 12 minus 24 is negative 12, but all of that is negative, so this turns into a positive 12. We have 24 minus 12 on this side, so we have 12 plus 12, and 24. So our answer overall is the area with those two pieces here of a sub 1 and a sub 2 is 24 altogether.